Children, now we have come to the concept of center of gravity. Center of gravity is something we have been mentioning in our equilibrium, or when we are studying our principle of moments or principle of equilibrium. We are talking about the center point. So let us try to understand what is this center point or center of gravity, which is also sometimes called center of mass. They are slightly different. So we will move on to the explanation a little later, but they are a little different. So let us start with the concept of center of gravity. Let us take a regular object. Regular object. Regular object, what does that mean? It means an object which has some line of symmetry. There is a line of symmetry. Now what does that mean? That means that if there is a heart-shaped object, alright, there is a heart-shaped object and there is a heart-shaped object, and if I draw a axis of rotation from here, axis of rotation, or can I say if I pivot it along this line AB, what happens? This shape is identical to this shape. So this can also be called as the line of symmetry. Line of symmetry is such a line along which the left hand side and the right hand side are identical. But what if I draw a line over here? Let's call this line CD. So if I draw a line CD, above CD we have this shape, and below CD we have a shape like this. So these two shapes are not identical. So this cannot be your line of symmetry. So we can say that a heart shape is a regular object if and only if the line of symmetry moves something like this. Let us take another regular object, a scale. Let us take a meter scale. Now let's say this is a 1 meter scale. What does it mean to be a 1 meter scale? It will have calibrations of 0 centimeter to 100 centimeter, isn't it? Here you will have 10 centimeter, 20, 30, 40. So here you will have calibrations like 10 centimeter mark, 20 centimeter mark, 30, 40, 50, 60, 70, 80, 90 and 100 centimeter. And this is your 0 centimeter. And this is your 100 centimeter. So if this is a uniform meter scale, what did I call it? A uniform. The word is important. Meter scale. Why is it uniform? It is uniform. That means that the distribution of the density in this scale is uniform. That means the scale, all the atoms or all the molecules of this alloy is arranged in such a manner that the scale has uniform fixed number of atoms at a given point of time. Or we can say that if I take a small part of this scale, the distribution of atoms or molecules of the material that it is made of is uniform. In simple words, we can say that the density of the scale is uniform. It does not have more molecules here and lesser molecules here. It is a uniform scale. It is made of the same uniform material. Alright, moving on. Now, for this uniform meter scale which we have at hand, if I make a line of symmetry like this, because this is passing from the center, this part is 50 centimeter long and this part is also 50 centimeter long. Together they are 100 centimeter long. So this can be a line of symmetry. Can I say this? So if I take the left hand side of the scale and the right hand side of the scale, both will weigh the same. Both will have the same masses. So by saying this, technically what all can we say? We can say that the force exerted by the left hand side of the scale is equal to the force exerted by the right hand side of the scale. That is what it means, because if this mass, this is mkg, this is mkg, correct? So what is the force exerted by left hand side? mkgf. What is the force exerted by the right hand side? mkgf. You should remember your gravitational units. You should remember your gravitational units. What are gravitational units? Gravitational units are units which are used when a body is in a state of free fall or it is under the influence of gravitational force. Why do we use gravitational units when the body is falling vertically down or moving vertically up? Because the acceleration that is caused on the body, is due to the gravitational force of the earth, is due to the gravitational force of earth. क्या है ये gravitational force of earth? This is earth. This is an object which is suspended somewhere inside the gravitational field of earth. Earth's gravitational field is limited, beyond which the field doesn't work. So let's say there is an object A. If it is suspended here, it will always fall downwards. Why will it fall downwards? It will fall downwards because earth exerts a gravitational pull on it. And when it falls downward, the motion is going to be accelerated. What does it mean for the motion to be accelerated? It means that the speed is going to increase with every given time, or you can say that at every time interval, if the speed here is 10 meter per second, here it might become 20 meter per second. Speed is increasing for every unit time, that is for every second. If you measure the speed keeps on increasing. That means the acceleration keeps on increasing. And luckily, for bodies which are under the influence of Earth's gravitational force, we know the value of acceleration. The value of acceleration is given by g. G is more or less equal to 9.8 meter per second square. G is approximately sometimes also taken as 10 meter per second square. That means when a body is under the influence of Earth's gravitational force, not of any other heavenly body, just Earth's gravitational force, the value of acceleration experienced by the body is equal to 10 meter per second square. Now, these are all your old concepts. Coming back to kgf. Now, every time we have to find the value of force, force is equal to mass into acceleration, correct? So, force is equal to m into g. Can we say this? When the body is under the influence of Earth's gravity. है कि नहीं? अर्थ के ग्रेविटी के इन्फ्लुएंस में जब भी कोई बॉडी होता है तब a का वैल्यू g हो जाता है और हमको पता है कि g का वैल्यू अप्रोक्सीमेटली 9.8 है. 9.8 is also approximate because earth is not entirely circular, okay, spherical, sorry. So now can I introduce another unit? I would say that force is equal to mass. ये mg अगर हम लिखते हैं, it can be Newton or Dyne. मास इंटू ग्रेविटी. न्यूटन क्या होता है? न्यूटन होता है kg मीटर पर सेकेंड स्क्वायर. That is unit of SI unit of mass into SI unit of acceleration, and dyne is gram centimeter per second square. SI unit of CGS unit of mass into CGS unit of acceleration. But I would like to remove this unit. I am not going to use the unit of acceleration as meter per second square. Instead, when a body is under the influence of Earth's gravitational field or Earth's gravitational force, I will simply write force as m kgf. क्या मतलब है ये? kgf is kilogram force. Kilogram force means the force exerted by Earth. The force exerted by the Earth's gravity on a body which weighs 1 kg. मतलब एक 1 kg के बॉडी को कितने फोर्स के साथ अर्थ पुल करेगा, that unit is represented as kgf. Let me make a small box here and let me show you how to write your kgf and Newton, how to find their values even. ठीक है? So if I say my mass is, let us do a quick calculation. If I say mass of an object is 60 kg, so there are two things we can do with this. We can say that the force acting on a body is equal to the weight of the body. This, correct? This can be said universally. Force acting on a body is equal to the force acting on a body is equal to the weight of the body. When is it possible? It is possible when the body is moving. When the body is moving downwards or upwards under the influence of Earth's gravity. Now, what does this mean? It means that if I say mass of an object is 60 kg and it is either moving downwards or moving upwards, what happens? This can be expressed in two ways. If the mass of an object is 60 kg, which is either moving upwards or downwards, that means that the body is under the influence of Earth's gravitational field. ये तो हमें पता है. So this can be expressed. The weight of the body is same as the force acting on the body. So weight of the body होता है F, force of the body, that is equal to ma, which is equal to mg, isn't it? So weight is equal to the force acting on the body. So force can be taken as the weight of the body. So weight can be expressed as mass, that is 60 kg into g. G का approximate value ले लो 9.8, or even better you take 10. That will be mentioned in your paper. Take value of g as 10 meter per second square or 9.8 meter per second square will be mentioned in your question if they want you to convert it to Newton. So weight of the body is 600 Newton. This is a long about way. But in your 10th standard ICSE, you are allowed to take the gravitational units, which is kgf and gf. So if I say that the weight of the body is 60 kg, so what will be the force acting due to gravity on the body? It will be 60 kgf. Story over. No need to add any 9.8 or any value of g. Simply we can say if the mass of the body is 60 kg, the weight of the body is 60 kgf. If mass of the body is 90 gram, the weight of the body is 90 kgf. Gram force. So if mass of the body is in gram, weight of the body will be given in gram force. Remember, this is only allowed when the body is moving upwards or downwards under the influence of Earth's gravity. Now let us come back to our meter scale. Now, this is your meter rule. So the marking calibration is 0. Calibration means marking, graduated numbers. 0. This is 100 centimeter mark. This is 10 centimeter, 20, 30, 40, 50, 60, 70, 80 and 90 centimeter each. So when I call this rod or a scale a uniform scale, when we call a body a uniform scale or a uniform body, that means there is equal density distribution all around the body. That means the number of molecules or atoms which are present on the left hand side, because this is half of the scale, this is 50 centimeter scale and this is half of the scale 50 centimeter. Both of them are identical in shape. Both of them are what? They are rectangles. So they are rectangles of equal area because this height and this height is also same. So this part has same number of molecules as this part. So can I say the weight of the left hand side is equal to the weight of the right hand side? So when weight of the left hand side, mass of the left hand side is equal to the mass of the right hand side. So weight of the left hand side is equal to the weight of the right hand side. So if left hand side and right hand side are exerting the same weight from both the sides. So let us quickly go back to our principle of moments. Left hand side tries to move the body towards the pivot. Let's say this is the pivot. This is the balance point or the pivot. Okay, I'm calling this the balance point or the pivot for now. Pivot क्या होता है हमें already पता है. Pivot is a point about which any particular body can rotate. So if this is the pivoted point, this is the point that I've held. That's not a point that does not move, or the scale is balanced on this particular point. So ML will try to move because of weight due to L. The body will try to move in the anti-clockwise manner, and because of the right hand side, it will again move towards the pivot. It will try to move with the clockwise manner. We know that the distances are same. Both are 50 centimeter from the end, correct? If both the sides of the scale is 50 centimeter from this side, the distance is 50 centimeter. From this side, the distance is 50 centimeter. Mass is also same. Weight is also same. So force due to left hand side is equal to force due to right hand side. Distance of left hand side. So S of left hand side is all distance of the rear end of left hand side is equal to distance of the rear end of the right hand side. So what happens due to principle of moments? The equilibrium can be achieved over here. Can we say that? Because clockwise moment here is equal to, clockwise कौन cause कर रहा है? Right hand side is equal to force due to right hand side into distance of right hand side. And anti-clockwise moment is caused by the left hand side. Can you see this? So force due to left hand side into distance of left hand side from the pivot. Correct? But here we know force of right hand side, force of left hand side are same. Distance of left and distance of right are also same. So can I say clockwise moment here is equal to anti-clockwise moment, which means that the body is in equilibrium. The body is in equilibrium. What does it mean practically for a body to be in equilibrium? Can I say the scale is at rest? So if I take this point OM, can I say the scale is at rest about the pivot? What is the name of the pivot? OM. Can I also say this point, the points about this over here? All the points over here. In fact, the point here at the center. This point at the center. Can you see this point? This point at the center, this point is the balancing point of the scale. Can I say this? Okay. Can I also say the total clockwise moment is equal to the total anti-clockwise moment at this point? I can say this. I have just proven this to you. Third, can I also say, if I want to take this whole body, in physics we try to condense the body into a point, because then otherwise we have to consider the shape of the body. When we are talking about motion, when we are talking about a body in any kind of motion, we try to convert it to point objects. So can I say that all the weights that are acting on the body, weight यहाँ से भी act कर रहा है, mass इस side का act कर रहा है, let's say the mass of the scale is 500 grams. This is a very important point that we are going to discuss right now. So now let us talk about the third point. This is an important point. All the points are important, but this is something you have to understand. This is a very logical thing. Now let's say the mass of the scale is 500 grams. Alright. So now tell me how much will be the mass of this side? It will be 250 grams because masses are equal, so they will be equally distributed. This is also 250 grams. Am I right? This is clear to you? Left hand side mass, because it is a uniform scale, that means it has equal mass distribution. It has equal density distribution, isn't it? So if the mass is 500 grams, the left hand side, the left half is 250 grams and the right hand side half is also 250 grams. So what is the mass and how much will be the mass and where will it act from? So what are the two questions? Total mass of the body or the mass of the scale, and where does it act from? The first answer is very simple. The total mass of the body is 500 grams. And where will it act from? Now, if I have such a large scale, 1 meter long scale, I want to condense it to a point. So we take into consideration the concept of center of gravity. What is the center of gravity? Center of gravity is such a point in a body. It can be a regular object, it can be an irregular object, it can be a uniform object, it can be a non-uniform object. But center of gravity exists for all bodies of all shapes and sizes. Center of gravity is such a point of a body from which we consider all the masses to act from. Center of gravity is such a point. Center of gravity is a concept that we have made up. This is our own hypothesis. This makes our calculations easier. So center of gravity is something that we have made up for making our calculations simpler. Center of gravity will be such a point where what are the things that happen? Let us consider. But where we say that all the forces that are acting on a body or all the weights that are acting on a body becomes zero. We will see this with certain examples, so it is easier for us to understand. I hope you have understood the scale, the meter scale, which we use very often for our examples. So in this meter scale, one very important thing to note is, I have explained this to you earlier also, but this is a very important thing that you have to remember always. The fulcrum or the balance can be at any point. So if I have a scale like this, if I balance it at the center at 50 centimeter mark for a 100 centimeter scale, then the mass of the body or the weight of the body is center of gravity, from which we say the weight of the body is acting. So center of gravity is also acting from point O, and the pivot is also at point O. So whatever be the mass of the body, what will be the moment that is caused due to the mass? Moment caused due to the mass for a body that is balanced at the center. Balanced at the center. मतलब मास जहां सेंटर ऑफ ग्रेविटी जहां से एक्ट कर रहा है, पॉइंट ओ से एक्ट कर रहा है, बिकॉज वी से सेंटर ऑफ ग्रेविटी इज द पॉइंट वेयर ऑल द मोमेंट्स बिकम इक्वल टू जीरो. करेक्ट? सो सेंटर ऑफ ग्रेविटी इज अ पॉइंट वेयर ऑल मोमेंट्स आर बिकमिंग इक्वल टू जीरो. उसी पॉइंट से मास एक्ट करता है बॉडी का, फोर्स एक्ट करता है उस बॉडी का, उसी पॉइंट पे बैलेंस भी कर रहे हैं. सो व्हाट इज द फोर्स इनटू डिस्प्लेसमेंट, दैट इज द टॉर्क caused by this body or caused on this scale due to the mass of the body, due to the mass of the body, not anything else that is hanging. I am not talking about any other external object. Simply due to the weight of the body itself, what will be the torque that will be experienced? It will be the force, that is 500 GF, correct, into the perpendicular distance of this force from the pivot. What is the perpendicular distance of this force from the pivot? Zero. So what will be the moment caused when the body is balanced at its center of gravity? The torque experienced by the body will be equal to zero. But this whole thing changes if I balance this scale, let's say at 60 centimeter mark. 60 centimeter mark पे scale को balance किया है, but center of gravity will always act from the center. So what if you have to find the turning effect experienced by this setup? This is at 50 centimeter mark because center of gravity will always be at the center of the body if it is a uniform body. But pivot can be shifted anywhere. So अभी ये body कहाँ जाएगा? Let us see. Now this is the force which is acting downwards because weight of the body acts from the center. Am I right? So now torque experienced due to the mass of the own scale. The mass of the scale itself will be equal to force experienced by the scale into perpendicular distance from the pivot. Am I right? So what will be the torque experienced in this second case? Torque experienced will be equal to force, that is equal to the mass expressed in GF, that is 500 GF, into the distance from the pivot. What is the distance from the pivot? Distance from the pivoted point is going to be 60 minus 50, isn't it? So the torque experience will be 500 GF into 10 centimeters. So the torque experienced will be 5000 GF centimeter. This is the torque which is experienced. So the moment the pivot is shifted, now this body will move anti-clockwise towards the pivot always. So this is experienced anti-clockwise. So can you see, without changing the body, if the pivot is shifted, the body will experience some torque. But if the pivot and the mass of the body, if the pivot is coincident with the center of gravity, if the pivot is coincident with the center of gravity, then due to the weight of the body itself, it will not experience any torque. Torque will be equal to zero. Only and only when pivot and CG are at the same point. Is this absolutely clear? Because now I'm going to quickly move to examples where you have to understand this concept very, very, very well. So now I'm going to quickly move to the examples and we will quickly go through all the examples because I think your concept is absolutely clear to you right now. Okay, now let us look at this toy. This is a rolling toy. It is also called as a CG toy or a rolling toy. There are different names for it. Look at what is happening. In this toy, it is moving ahead. It can also move back. But it will not fall or it will not topple. Why? Because look, the center of gravity of this body or this toy is over here, which means that all the forces or all the moments become equal to 0 at this point. So this is the balancing point of the body. ये भी बोल सकते हैं हम. This is called as the balancing point of the body. So now when this body is moving ahead, still the center of gravity is over here. When the body is moving back, still the center of gravity is retained over here. If the center of gravity would have shifted over here, then the body would have become unbalanced. But if the center of gravity is not moving anywhere, that means the body is balanced at this point. And center of gravity of a body does not really change. Now let us look at some properties. So children, whatever we have discussed, let us see once again what is center of gravity. Whenever we look at a body, let's say this is any kind of shape. So some weights will act from here because this is an irregular shape. So something will try to pull it down from here. Some weight will try to pull it down like this. Some will try to pull it down like this. So let's say net of all the weights that are acting on this body can be given as W1, W2, W3, W4 and so on. So from all the sides, if we consider some weight, if it is an irregular object or a regular object, for example, for a regular object, weight is acting downwards from here, from every point. So we take it as a cumulative thing as 1. We take it as a cumulative thing as 1 weight. Here also that's why we try to take a cumulative weight which is the center of the gravity of the body. Okay. Center of gravity is a fixed point where the algebraic sum of the moments due to all the weights become equal to 0. So we just saw it for the scale. The left hand side moment, that is the clockwise moments, and the anti-clockwise moment, the point where it becomes equal to 0 is called as the center of gravity. Now, center of gravity So let us look at some important points related to center of gravity. Center of gravity is a fixed point about which the algebraic sum of all moments due to the weight becomes equal to 0. That's exactly what we discussed just now with our meter scale. Okay. Center of gravity will not change. However you place the object, the center of gravity will remain exactly there. It will not change. So the first point that we have to note is center of gravity of a given mass depends on its shape and not its mass. Matlab center of gravity of a given body, can we say, depends on its shape, but it does not depend on its mass. Let us see what are we trying to say over here. Let's look at this example. Now here there is this one person, same person, who is doing 3 different poses of yoga. So this is the position A where they are standing straight. This is where the center of gravity is. But when they are standing a little tilted, so you can say the leg is raised like this. Now the shape of the body has changed. Mass is the same, it's the same body, but the shape of the body has changed. So here the center of gravity is going to shift a little bit towards the side which has more, which has more protrusion. This is a protrusion. This is an extra, extra elongation of the leg. Now here the protrusion is more on the left hand side. The most mass of the body is on the left hand side. So here the center of gravity will shift like this. Now if the person would have tilted even more, I'm just trying to explain the significance, so please don't go on my horrific diagram. What if I tilt even more? So what if a person tilts something like this? So two legs are like this, hands are like this, and the person is tilted fully at 90 degree. If this is how a person is standing. Okay, these are the feet. So in this case, this part has a majority of the mass of the body. So the center of gravity can possibly shift outside the body, and whenever the center of gravity shifts outside the body topples over. What happens? It topples over. Why? Because it has lost balance at this point. Okay, but this is not true for all objects, because some objects can have their natural center of gravity outside their body. Let us look at the third point. So did you understand this point? Center of gravity can change only when the shape of the body changes, not the mass of the body. So this person can be of 10 kgs, 100 kgs or 500 kgs. The center of gravity will remain wherever the center of gravity will remain at a point where all the moments become equal to 0. That is the symmetrical center of the body for symmetrical objects, and this will not change if the person becomes fatter. If this person becomes fat, still the center of gravity will remain exactly there. But when we talk about pregnant women, there is a little bit of protrusion of their tummy. So in that case, the center of gravity can move back and front. Why? Because the shape of the body is changing. So the mass or density does not matter, but the shape of the body is way more relevant for center of gravity. But sometimes when mass of the body increases, the shape also kind of changes. So that will have a passive effect, but not a direct effect. Now, the second point is, the center of gravity is not always within the material of the body. If I take a circular ring. So this part is hollow. So the center of gravity lies outside the body. If I take the same ring, let's say this ring's radius is r. Okay. So what is going to be the length of the ring? Let's take the radius as 7 centimeter. So what will be the length of the ring? Length of the ring will be equal to 2 pi r. That's the circumference, that is 2 into 22 by 7 into 7. That is equal to 44 centimeter will be the length of the ring. Correct? So what I did is, I took this ring and I converted it into a straight line, which is a straight rod. So the length of the rod is going to be 44 centimeter. So tell me, now where will the center of gravity lie? The center of gravity, because we are talking about a uniform object over here, uniform. So the rod is also uniform. I have just taken this ring and I have opened this up. So in this case, the center of gravity is lying well within the ring, at the center of the ring at 22 centimeter from both ends. Yes or no? So the ring is the same thing, made of the same material, but the moment I change the shape of the ring, the center of gravity shifts. It is somewhere else. Alright. Next. So by the concept of center of gravity, the body of net weight, any given weight W, will act from its center of gravity. That means whenever we talk about center of gravity for any shaped object, the center of gravity will always act from such a point where all the moments become equal to 0. So then we stop considering the shape of the body. We only say it is a point object of weight W, which is a collection of all the weights from all the ends of the body, from all the sides of the regular or irregular body. This side has certain weight, this side has certain weight, this part has certain weight, this part has certain weight. So the accumulation of all weights is said to be acting from the CG for practical purposes. Since the center of gravity of a body is a point where all the sum of moments become equal to 0, this we have verified with our scale, it is also called as the balance point of the body. Alright, so understand this concept very clearly. Center of gravity does not depend on the mass, it only depends on the shape of the body. Center of gravity is not always at the center of the body. Center of gravity is a point that we consider for practical purposes that's where the point, that is the point object from where the entire mass or entire weight of the body is acting from, and center of gravity is a point where all the moments about the point become equal to 0. Therefore, this point is called as the balancing point. Now, very important note for all of you. Very, very important. Something very important about a balance point. Balance point is a point where naturally the moments acting on the body becomes equal to 0. This is not a body. This is not a point where I am balancing the body. If I say there is an object like this, whose balance point is here, that means its center of gravity is here. This is a point if and only if I end up balancing this figure on this point, the body will be stable. If and only if balanced at center of gravity, body will be stable. Okay, but if I want, I can balance it at this point also. But if I try to balance the body at this point, the body will topple. So understand this thing. Balance point is a natural point that if at that point if I balance the body will be stable. But if I want to, I can shift the pivot anywhere I want, but there is no guarantee that the body is going to be stable. The body is going to be stable only and only if CG, that is the center of gravity of that given body, and pivot is a thing that we apply. Pivot is a point or a balance that we apply, like a finger or a pivot scale or a center point. We apply that. Whenever we apply that pivot on the CG, the body is going to be balanced. But if this pivot is not coincident with the CG, that means it is not at the same point as the CG, the body is 100% going to be unbalanced. We saw this example, we saw the demonstration. What is happening over here? This is a uniform bird. So, if the center of gravity will lie somewhere along this point. So, the center of gravity is actually over here. So, if the pivot is set, this is the pivot in this case. If the pivot or an external pivot or an external balancing point is coincident matlab kya? On the same point. If this is your pivot and this is also your CG, can you see how the bird is balanced? But now, if I shift the pivot somewhere over here, then the bird will topple. How will it topple? It will topple clockwise. If I place the pivot somewhere over here, the bird will topple. Why will it topple? This is the center of gravity. This is the center of gravity. So, this is where the weight of the body will act from. अभी यहाँ से weight act कर रहा है, यहाँ पे है pivot, it will move anti-clockwise, correct? Now, what if I take this same pivot and if I balance it over here, somewhere over here, यहाँ पे balance किया, this does not exist. Now, this is where the center of gravity is. This is how the weight will act. Where will it try to go? It will try to go backwards. It will try to go towards the pivot, isn't it? It will always try to go towards the pivot. So how will it move? It will also move, try to see this in the vertical sense, it will move anti-clockwise. Here it is backwards, but you can see that the motion, if you try to go towards the pivot from point A to the pivot at point B, the motion is actually anti-clockwise. Alright, I think you should be able to Verify all this in your own space. Now we are looking at some common examples. Let us see. Now we are going to see the center of gravity of some common objects. This is a square, so the center of gravity will be at a point where both the diagonals meet. This is a circle, again two diameters, any two diameters, they meet at this point. For a regular shaped rectangle also, it is at the point of intersection of diagonals. What about a triangle, a scalene triangle? So if we can talk about a general triangle, which is a scalene triangle, we can find for all triangles, it is a point of intersection of all . It is a point of intersection where all medians meet. Medians मतलब क्या होता है? Medians is a line which joins the midpoint of a base from the opposite vertex. So if this is the midpoint of this side, the line which joins this midpoint with the opposite vertex is called as the median. How many medians will a triangle have? 3, because there are 3 vertices and 3 sides. So wherever the medians meet is the point about which you can balance the triangle. When you are talking about a circular ring, when you are talking about a disc, the center of gravity lies at its center. When you talk about the ring, this also lies at its center, but the ring is hollow. So basically, the center of gravity of a hollow object always lies outside the object. If this rectangle would have been hollow, this center of gravity where the diagonals meet also would have been outside the object. This is a spherical, this is a cylindrical object. Center of gravity lies at height h2 from both bottom and top. This is your cone. For a cone, the center of gravity, this is a solid cone. Remember, solid cone center of gravity lies at a height h by 4. If the whole height is h, if the entire height of the cone is h, so center of gravity lies at h by 4 from the bottom. That means it lies towards the bottom. Why does that happen? That happens because more mass is concentrated here. More weight is exerted in the lower part because it is heavier, it is bulkier. Okay. And if you have to find from the top, it will be 3/4 of h from the top of the cone. The moment it becomes a hollow cone, that means the bulk has decreased. It is less bulky. So that's why the height of the center of gravity moves a little upwards. Now it is h by 3. H by 3 is greater than h by 4. Isn't it? So now the height has gone a little upwards. Why? Why has the center of gravity moved a little upwards? Because when it is a solid cone, a lot of mass is concentrated in the bottom part. But when it becomes a hollow cone, the mass at the bottom is much lesser because it's air or vacuum that fills it. So there is another point that we have to note, that center of gravity shifts towards more mass. क्या मतलब हुआ इसका? If there is an arrangement like this where both are 1 Newton each, so the center of gravity will be at the center. If the distance is 2 meters, the center of gravity will be at a distance of 1 meter from both the sides. Yes. But if this is 1 Newton, this is held by 2 Newton, this distance is 2 meters, the center of gravity will shift towards the bigger weight. So the center of gravity will shift a little towards the right. So center of gravity is not exactly always at the geometrical center. It depends completely on the mass distribution. It depends on the shape of the object. Mass distribution मतलब ही shape of the object. ये shape change हो गया कि नहीं? Here there is more mass. Here there is equal mass.